Welcome to Spring Lib.
Hi, given the vectors v1, v2, v3 are linearly independent set of vectors in Rn, which of the following is linearly independent set? So first set is v1, 3v1 plus v2, 4v2 plus v3. Now so let us take the linear combination c1v1 plus c2, 3v1 plus v2 plus c3, 4v2 plus v3. So we can write this as v1 c1 plus 3c2 plus v2 c2 plus 4c3 and plus v3 c3. Now since v1, v2, v3 are independent, so we must have c1 plus 3c2 equal to 0 by definition of linear independence, c2 plus 4c3 equal to 0 and c3 equal to 0. Now c3 is 0, so putting over here we get c2 is also 0, and from here we get c1 is 0. So therefore we get c1 equal to 0 equal to c2 equal to c3. So this set is linearly independent. Now the next one is 4v1, 3v2 and 6v3. This is clearly linearly dependent set. Now third we have v1 minus 8v2, 4v2 minus 4v3 and v1 minus 8v3. So clearly again we will use the definition c1 v1 minus 8v2 plus c2 4c2 4v2 minus 4v3 plus c3 v1 minus 8v3. So we can write this as v1 c1 plus c3 plus v2 minus 8c1 plus 4c2 and plus v3 minus 4c2 minus 8c3. So now since v1 and v2, v3 are linearly independent, so these must be 0. c1 plus c3 must be equal to 0, minus 8c1 plus 4c2 equal to 0 and minus 4c2 minus 8c3 equal to 0. Now from here we get c1 is equal to minus c3. So putting over here we get the relation between c2 and c3 as c2 as equal to 2c3 by putting c1 to be minus c3, and from here we get c3, c2 to be c3 and then this to be c3, so we get c3 0. So from here we get c2 0 and from here we get c1 0. So again we have arrived at c1 is equal to 0 is equal to c2 is equal to 0 is equal to c3 is equal to 0. So this set is linearly independent. And the last one is 3v2, 6v2, 4v3. This is clearly linearly dependent. So therefore the correct answer to this problem becomes the linearly independent sets are v1, 3v1 plus v2, 4v2 plus v3, which is option 1, and v1 minus 8v2, 4v2 minus 4v3, v1 minus 8v3, which is option 2. Hope you find the video useful. Thank you.